Hi everyone, welcome to my channel. In this video, we will see about Tellegan's theorem. The statement for Tellegan's theorem is, in any linear bilateral network consisting of active and passive elements, the power delivered by the active sources is equal to power absorbed by the passive elements in the given network. So we know that the given network consisting of both active and passive elements, and we know that active elements are the elements which are delivering the power, passive elements are the elements which are receiving the power. Upon receiving the power, either they can dissipate the power or absorb the power. So whatever the power that is generated by the active elements, that should be consumed in the passive elements. We know the active elements are nothing but voltage sources, current sources, batteries, etc. Passive elements are nothing but RLC elements. So whatever the power that is generated or delivered by these active elements, that should be is equal to the power consumption or power absorption in the passive elements. So power delivered is equal to power absorbed or power consumed, that is dissipated. So that means the network may be consisting of both resistive elements, inductor and capacitive elements. If the supply is AC, so the resistor element which can dissipate the power, whereas the inductor and capacitor can store the power. Whereas if the circuit is pure DC circuit, so only the resistive element is present, that means the energy consumption will be takes place. Therefore power generated by the voltage source or battery is equal to power dissipated in the resistor. So we'll see an example so that you can understand easily. So the first problem is verify Tellegan's theorem for the given network. So it is a DC circuit, so having two sources, one is 25 volt source, the other one is 15 volt source. So by applying the KVL in the two loops, so we are getting the current values I1 and I2. So in the 6 ohm resistance, the two currents are flowing in the same direction. Therefore, by adding the two currents I1 and I2, we are getting the current in the 6 ohms. Let that current is I3. So by writing the KVL equations in the two loops and solving the equations 1 and 2, we are getting the two currents I1 and I2. So upon getting the values of I1 and I2, the current in the 6 ohm resistor is the summation of the two currents I1 and I2. Therefore, we are getting the I3 current. So after getting the three currents, we have to calculate the total power supplied by the two batteries. Here in the given circuit we have two batteries, so the power supplied by the 25 volts battery is V into Y. The power formula is V into I. Therefore V is 25 volts, I is nothing but I1. Therefore 25 into I1 is the power dissipated, power delivered by the source. Similarly 15 into I2 is nothing but the power which is delivered by this 15 volts source. Therefore adding the two powers, we are getting the total power delivered by the two sources. So that is given as equation A. So and it is designated with P1. So next, if we calculate the total power dissipated in all the resistors, we have in the given network three resistors are there. Therefore we have three power dissipations. So the power dissipation formula is I square R. Therefore in the 10 ohm resistor, I1 square into resistance is 10 ohms. In the 12 ohm resistor, I2 square into 12. In the 6 ohm resistor, the summation of the two currents, that is I3. Therefore I3 square into 6 ohms. Therefore upon adding the three power consumptions, we are getting the power P2. So if you observe the powers equations A and B, so the power delivered by the source, that is all the sources in the given network, that is equal to the power dissipated in the all the resistors. Hence the Tellegan's theorem is proved. So second problem is, so here in the given problem we have only one source. He asked to verify the Thevenin theorem. So whatever the power delivered by this 10 volt source, that should be consumed in all the resistors. For that we have to calculate the currents in each and every branch. So for that we have you can apply KCL or KVL, node analysis, mesh analysis, whatever the technique you know that which is familiar to you. So here I am applying the KVL in the three loops. So for the calculations of three currents I1 and I2 and I3, so upon writing the KVL equations and simplifying the three equations, we are getting the three currents I1, I2 and I3. So if you observe the circuit, so the power delivered by the 10 volts battery is 10 into I1. So that is equation A, that is a power delivered by the source. So if you observe the remaining all the resistors, we have total 5 resistors in the given network. In the resistor 5 ohm, the current I3 is flowing. In the resistor 2 ohms, So the difference of the two currents I1 and I3 that is flowing in the resistance 4 ohms, the difference of the currents I1 and I2 is flowing. In the resistance 6 ohms, the difference of the two currents I2 and I3 is flowing. Similarly in the 8 ohm resistor only I2 current is flowing. So after calculating the currents in all the branches, so then we have to calculate the power dissipated in all the resistors. So we have total 5 resistors. 5 resistors are there. Therefore, we are getting the 5 different power consumptions. Therefore, adding all the power consumptions, that should be is equal to 24.38, which is nothing but the power delivered by the supply. So that is mentioned in the equation A. Therefore, from equations A and B, P1 is equal to P2. The two powers are equal. That is power delivered by the source is equal to power consumption in the power dissipated in the all the resistors in the given network. Hence, the Tellegan's theorem is proved. Thank you.